So the talk you're at right now, in case you've missed the large slide here up to my left, we're going to be talking about theming GWT applications with the appearance pattern. My name is Colin Alworth. I work with Sencha on the GXT library of widgets for GWT. So how many people here are using GXT, first of all? All right, a handful of people. How many people are here because they want to figure out how to theme GXT in an easier way? Okay, a little bit of laughing there. So big fans of the appearance pattern? Who here loves the appearance pattern? Oh boy, all right. A couple of people, all right. And who here is then here because they're either interested in learning about GXT? All right, and how about people who are here to learn about the appearance pattern and how they can use that when designing their own widgets or their own applications? All right, a lot of people, all right. So hopefully I'm going to really address the appearance pattern itself in this talk, and a little bit how it relates to GXT, but mostly what is it, why do we spend so much time working around it, and what kinds of things can we do to make this easier, and what really advantages do we get from it. So what's the history? First of all, about 3 years ago, the Cell API came out as part of GWT. The appearance pattern came out as part of a very small wiki document. It's still on code Google.com as part of the general Cell API. There was a little bit of a discussion about how do we make it easier to theme these things? How do we make it easier to not only change the CSS, but the HTML structure? How do we let people factor all these pieces out? Much like we've got MVP to factor out a lot of the logic in your application from how it looks. It's a way to say, well, we've got logical pieces in how our widgets work or our cells work, and then we've actually got the display details. And we picked up on that document and thought that looked interesting, and we worked through it for a little while, and we had a couple issues. And about 2 years ago then, at Senchacon 2011, GXT3 preview was released. And this was a precursor to the actual GXT3 that's out and used by a number of companies today. And we touted the appearance pattern as a way to do our theming, as a way to stop having a monolithic CSS file that contains the CSS for every single widget in the library, but instead to enable the compiler to only select the CSS we need. And we get all kinds of other fun stuff from client bundles, and we talked more about X templates. And then just about a year ago, GXT3.0.0 was released, and it used the Cell API in its fields and appearances everywhere. It used the Cell API in its fields, and every widget used the appearance. Every single widget inside of GXT is built using the appearance pattern that we're going to talk about. And it uses that to be able to say exactly how do we theme and how do we change those theme pieces without redundant amount of CSS, and making the CSS then part of the application. So getting started then, what is the appearance pattern? For those of us who haven't read the document or haven't pored over GXT trying to figure out exactly what were they thinking when they put that together, the appearance pattern is a basic way to abstract out the drawing details of a widget. And there's three main responsibilities you've got. First, you've got to render the initial content of the widget, put together the HTML that is used to draw the widget on the page. You have to update the content based on any changes that happen, or any interaction that happens from the user. So the changes could be that you change the value of the field programmatically. The interaction from the user could be that they click the button, so we need to change how it's drawn slightly. Or we click on a collapse icon, the whole thing needs to come up, the panel needs to shrink. And then finally, we need to answer questions about the existing rendered content. The cell or the widget needs to be able to say, am I currently expanded? Or where did the user just click? Because the cell or the widget doesn't know exactly how the widget might be drawn, it has to ask the appearance, for the thing that just happened, how do I figure out what just happened? So rather than digging into code, because code on a small screen like this doesn't always work very well for the whole room to be able to understand, I'm going to be trying to come at this by way of a couple of examples. So first, the prototypical example that was used in the initial wiki article, a button. So when we render a button, at least in GXT, this goes into slightly more depth than the original article did, we need to be able to render the text. We need to be able to draw an icon, so you may have a little bit of text and an icon, both drawn inside the button. We need to update for changes, and once again, those changes can be changing the text or changing the icon, maybe stretching the button to be a little bit wider because you want a little white space on either side. We also need to update for user interaction. If you hover the mouse over a button, you expect it to change slightly to give you an indication that you're allowed to click on it. You also could say, when you focus on it, when I tab to it, I want it to light up. That way I can, as the user, I can see exactly what's focused. And of course, when I put the mouse down, I want to see it get depressed in, and when I lift the mouse back up again, I want to have it pressed back up again. I'm also going to need to ask questions as the cell or as the widget to say, how do I figure out where to focus on this button? For a button, it's less important, at least for a standard button, because there's just going to be the top level element is usually the focus element. But programmatically, I might say, when I display a window, please focus this widget. And the widget internally says, okay, hey appearance, where do I put the focus? And the appearance in turn says, this element is where you put the focus. And then we call focus on that instead. In the case of GXT buttons, in some cases we need to be able to have one area that when you click on them, it just depresses the button and activates something. But on another part of it, you might activate a menu that you can have a drop down to say save or save as and save somewhere else. So we need to be able to ask the appearance, did the user click on the menu part or did they click on the regular button part? From the widget, we have to be able to ask this question to the button appearance. Another example then, the text field. We need to be able to render it with a value and with various options. And for those of us who use GXT, what options might those be on a text field? Any ideas? Could be if it's read-only, because we need to tell the appearance so that it sets certain attributes on the input to say don't allow the user to change things. Another one is if it's empty, if there is no value and we're supposed to display empty text to indicate to the user, enter your username here. We need to be able to pass that along. And then we'll need to be able to update the value in the options. We'll need to say, please change the value because programmatically I was just informed to set value, change that value, or please change the options. I was just given a different set of empty text to display here. And then likewise, we've got updates for changes in the value, in the state of it, usually from the user. Focus is the main one there, I guess value I just mentioned before. And I have it twice on the slide. And then whether or not it's empty or not. Not only the empty text, but whether or not it should be considered to be empty. And then once again, we need to find the focus element to say, where exactly do I deliver focus in here? Text field is more important to find the focus because you could have other wrapper elements around it to say, draw a nice border here, and then another container here to get sizing right, and then finally draw the real thing. And then one more example we're going to look at, a panel. A panel is the only container we've looked at of these three examples. In the case of a panel, we're basically rendering static content. We need to figure out, here's the header, buttons go down here, main content goes in here, wrap the whole thing up with one more element. And then we need to update to perhaps show and hide the header, or perhaps collapse, expand the panel. And that may include animation, which could either be in the widget itself or in the appearance. And then we'll need to ask for icons to say, okay, exactly where do we, or what kind of icon do I use for this panel? Which icon should I display as the minimize button or as the maximize button? What elements hold the title? So as the panel widget is saying, I need to change the text, or I need to add a widget to the title, add a widget to the content, or add a widget to the button bar at the bottom. We need to be able to ask, where do these things belong? How much space do I have? How do I handle the sizing for all these different areas? So depending on the widget we look at, there's different considerations that the appearance contract itself needs to take into account. But they all, as I said, boil down to these three main points. So in the appearance contract, we have the appearance control all rendered HTML. It decides what actually makes it to the DOM. It decides how to change that. And it completely takes that away from the widget so that it can control that completely. The widget, on the other hand, deals with all the logical details because it's its responsibility to say, what do I do when I get a new value? Do I need to change something? Do I need to draw something else? Do I need to alert the user? Do I need to call a callback or fire an event handler? And the appearance implementation can choose to use or ignore state changes. So if you're implementing, for example, a button and you decide, well, I don't actually care about focus state. I don't need to worry about that. Or I can use the browser's own focus state. As long as the element has the pseudo-selector :focus, then it will automatically pick up the changes. So I don't actually need to listen to these methods. So you can go ahead and ignore whatever details you choose to leave out, but the widget will still call them. The widget doesn't know you're ignoring them. It'll still automatically call them. So what kind of exceptions do we have to this? Where do things break down a little bit? So in both the ColorPalette and the DatePicker, we need to have the widget know a little more about exactly how things are rendered. So in a DatePicker, for example, or well, in a the color picker, for example, you might have the user selecting one color, and then they use the keyboard to try to move to a different one. They use one of the arrow keys. And while the widget may have told the color picker, here's the colors, don't really worry about where they're drawn, you figure it out. It's the appearance's job, of course, to write all the HTML, to figure out where it goes. But now the widget wants to say, I want to move one to the left, but it needs to know the value. But value really isn't the job of the appearance, it's the widget's job to figure that out. So instead what the widget has to do is ask, okay, if I move one to the left, where am I? Which cell am I in now? Can I take it for granted that you're drawing a table of some kind, or a grid of some kind? If this is currently selected, what's one to the left of me? What am I going to see if I switch over here? So it can ask the appearance to say, what's one to the left if I make this assumption about how you've drawn? And this does break things down a little bit. It does make it a little bit harder to write these appearances, but it does make it a lot easier in the long term to be able to keep these two in sync, to be able to add more logical details. Tree and grid are another example. We've got a different set of issues we need to worry about. We no longer need to say exactly where things are based on key navigation. But instead we need to worry about performance. When we're drawing 1,000 items and each of those items has 10 or 20 columns we need to worry about, that's a lot of content to spit out on the page. So anything we can do to say, guarantee that the grid knows exactly where things are and can find things instantly is important. So in this case, we again cheat a little bit and say, okay, the grid actually knows what kind of content you're drawing. You're probably drawing a table. There's probably a TR in here. There's probably a TD element inside of the TR. We're going to make these assumptions. The implementation of the grid appearance has to follow these certain rules to make sure that we can get the efficiency we need as a library. But for the most part, beyond those cases, we have these three basic pieces and the responsibilities are divided accordingly. So it's been our experience that implementations of appearances should be stateless. They may have fields, but those fields should be final. You set them once and you're done. And usually they get constant values. And there's two reasons we do this. And the first one is that if you have a cell, anyone use the cell API here? Anyone built any cells, either with Wit cell table or with GXT's grid? A couple of people? Okay. So one of the interesting things about cells is that they tend to render the same content over and over and over again. You use one cell instance, and it renders its content maybe 10, maybe 100, maybe 1,000 times with just one object. And it turns out to be very efficient to draw in that way. But because the cell only has one appearance object, if the appearance is keeping track of each individual bit of rendered content, it's going to have lots of copies of data. So instead we say the appearance should not keep track of which particular row it's in, which particular column it's in, which element it's drawing. And this in turn means that all the methods in an appearance typically take some kind of context. Here's the element you drew when I asked you to render, and here's the direction I want you to take when you start doing something to it. We usually pass in a parent element, and this is a lot what it looks like when you're using a cell API. So we need our appearances to behave well for cells if we end up using them there. And it also turns out that if we have no stateful stuff, there's no this that's referenced inside of each method, the compiler can rewrite that method to be static and final. And once a method is static and final, the compiler can say, okay, you only call this method from one place or from two places. Let me just go ahead and move all that content back to where you're calling it. So it ends up being that provided you use exactly one instance of an appearance, there's essentially zero overhead. All the abstraction we do here to break this out into two pieces is gone by the time we compile. It ends up being just one class. So that's the appearance contract itself to say exactly, why do we make these things this way? What methods do we have? When we build appearances, how do we actually instantiate them? And this again is responsibility of the library author, of the widget author, to say, I've created the widget, I have an idea what I need, I've created the appearance pattern to say, how do I describe what I need from whoever is implementing this? How do I get an appearance instance now? And typically, those widgets will invoke GWT.create to say, give me an appearance that implements this interface. And then in your module file, in your GWT.xml file, you typically have replace with rules that say, when you see this interface, go ahead and provide me with this instance. So, for example, we might have a rule like, when you see the info appearance, please give me the Neptune info appearance implementation. And this is a concrete implementation that has its specific HTML, its specific CSS, and its own wiring to handle all the update rules and all the methods that ask questions about how it's currently rendered. So we do this automatically in GXT. We've got a full set of the blue theme, we've got a set of the gray theme. Each module describes how do we wire these things up. But what if we want to change back and forth then between these two things? And this is something we're adding in GXT 3.1, the zip file you've all already got, and in our generated themes. We can add an extra line saying, if you see this interface, info appearance, and the property GXT theme is set to Neptune, then provide the Neptune info appearance. This way you can design your own appearance and say, when someone switches from Neptune to my own appearance, switch to this implementation instead. This is just like the locale setup that GWT already has, just like the user agent setup that GWT already has. If you ask it to, it'll generate new permutations based on all the different themes you've requested it to build with. Anyone use this before? Replace with rules? Or generate with rules? Okay, fair number of people. Great. So when you're building these, there's a couple of tips to keep in mind. Widgets generally then should expose an appearance constructor. So we already have a default appearance that each widget gets built with. And you might have 10, 15 buttons drawn across your application, for example, but maybe you've got one that needs to be drawn differently. We recommend that widgets should expose an appearance constructor. That way, in a particular case where you're building a button, you want to have a custom appearance, you can pass that custom appearance in, instead of trying to put this bookkeeping somehow in the appearance implementation itself. You can have more than one implementation you're using for the application. We typically suggest that inside the widget or the cell itself, the field that holds the appearance should be both private and final. And this annoys people who are extending widgets sometimes. We'll get to that in just a moment. But the main thing this solves, the main problem that this avoids, is a case where someone says, I've got a widget, I created it once with one appearance, but now I want to switch to this other appearance without changing anything. Well, the initial appearance drew one DOM structure and made one set of assumptions about how it would be drawn. Once we switch to another one, we'd have to know to re-render all the content, and there's possibly other things that would need to get dealt with. The appearance can technically do anything at once, and we want to make sure to avoid any cases where one hasn't finished doing its cleanup before the other one gets drawn. So rather than doing any of that bookkeeping, we just say make a new appearance, or sorry, make a new widget with the new appearance. And then for those widgets that eventually have subclasses that need to interact with their appearance, we recommend instead that they have a getter to expose that appearance instance. And this lets you say if I make a panel that has one particular appearance, and then I have a panel that does something else, it draws sideways, it has the text drawn sideways. You can subclass the panel, and you can override getAppearance to return some subtype of the appearance. Is that making sense? People vaguely following along here? I know this is sort of a technical topic, and unfortunately we don't have a lot of other information other than just trying to pour all of this on you and see exactly what we get away with here. So there'll be lots of time for questions at the end. We typically find it's helpful to have default appearances that themselves are easy to extend. So in addition to having widgets that are easy to provide one appearance and then a second appearance, we also think it's helpful to have the appearance itself have a non-default constructor. Have a constructor that takes the CSS styles or the images that you use to draw it with. That way someone can easily subclass and they don't need to change all the various rules. They don't need to change what HTML it renders. They just need to say, do exactly what you're normally doing, but now also use this CSS instead, or also change this one CSS selector from here to here instead. And then finally, appearances shouldn't use generics, because GWT.create doesn't actually use any generics when it does its pattern matching rules, because in Java, generics are all erased. So if you specify in this, for some particular widget that it should be generic on some T, and then you've got a widget that uses T where it's string, and then you've got an implementation that uses double, the compiler will never be able to figure out that you can't actually match these together. So avoiding generics is very important. It's important to keep all this type detail inside the widget or inside the cell, and let the appearance just worry about how does it actually, bang on the DOM, make the HTML show up, make the changes it requires. Okay, so let's look at an example of how we'd actually build something here. And I've looked at the info class. In GXT, you've got a method called info can't remember what the method is called. We'll see it in just another slide or so. But we're displaying a quick message on the screen saying, hey, there's a little bit of detail you should know about, and then it disappears after a few seconds. So typically when we do these render methods, we find it's helpful to either use Safe HTML Builder or Safe HTML. When we've defined the interface, we pick which one we're doing. And then when you're implementing it, you pick either Xtemplates, Safe HTML Builder, or handwritten Java to say, here's exactly how I want you to draw this. Anyone here using Safe HTML Builder anywhere in their apps? Or Safe HTML Templates? Okay, how about Xtemplates? Okay, Xtemplates is a GXT-specific class that is basically Safe HTML templates. But instead of doing the numbered arguments, we've got named arguments in here with the dot notation. So we pass in a style object into the template, and we can say style.infowrap. Call the infowrap method to get the string you need to put in here, or use the infowrap property. And then likewise for the second div, we've got style.info to say what we put in here. So the info appearance that we're looking at in this case just takes two divs to draw. One outer div, one inner div, content goes inside of there. And then the render method gets pretty simple then. We've got a field somewhere called template, we've got a field somewhere called styles, and when render gets called, we say safe HTML builder.append, and then render the template with the styles. It will automatically generate the HTML it needs there, and pass it up to the parent and say, here's my rendered content. Okay, so far so good. What's next? We've got a render, we've got two other responsibilities. What's the next one? Either one of them? Anybody? We've got to be able to find individual elements we've already drawn to ask questions, and we've got to update the existing elements. Now it turns out for info, this is actually pretty straightforward. There's nothing to update. The way info works is we reuse objects over and over again, and we just completely clobber the existing content, replace it with something new. So all we need to be able to do is ask, where's the content element? So for the HTML we looked at here, if you pass in the outer element, the parent, and I want to figure out where do I put my content, it's pretty straightforward. I say parent, get first child element. Since there's only likely to be one implementation of this, as we mentioned before, the compiler is going to go ahead and inline this method somewhere else, so we're not even going to have this method by the time we finish compiling. So when we implement an appearance, we declare a default constructor. When you use replace with or GWT.create to say build me something, it's going to look around, it's going to find the type, and it's going to try to call the default constructor. If it can't call that, you're going to get an exception. You won't even be able to compile. So you have to have a default constructor. That way, replace with can return your type and create the new appearance object. And if it makes sense for your case, is someone likely to extend your appearance and change it slightly? Then you should make sure the type can be extended. Have a second a second constructor, which takes a client bundle or some CSS resource that they can extend and change. So there's two parts to this topic, this whole discussion here. We've got the appearances, and we've got the theming piece. And this is sort of the point where we cross over from each individual appearance. We say we can theme a button in one way, we can theme a text field in one way, the info pop up the panel. And now we want to start bringing all these together into a theme. How do we start thinking in terms of themes? Themes that are drawing in some sort of consistent way. And I'm going to decide that a definition for a theme here is a consistent set of appearances. These are usually defined in one module. So you put together a module with the name of your theme, and that module is made up of replace with. Each replace with line says, okay, we've got, when you find this particular interface, use my themes instant here, use it my themes instance here, and change each one over. So these module files end up being very, very long, because for every widget you might possibly want to replace, you have to have one of these replace with rules throughout the file. In GWT.create, we've made them ever so slightly longer still by putting one of the when property is lines in each one. That way you can specify, please compile an app that has blue, gray, and Neptune, for example. And the app will work automatically in all of these. So what this looks like, very briefly, is a drop-down that lets you say, okay, how do I switch from blue theme to gray theme? I just click something else here, and unfortunately I made the mistake of actually clicking on that button. But the hotel Wi-Fi is running a little slow right now, so we may actually never see that finish. Let's just try the slides and pretend I hadn't been foolish enough to click that. So who here has tried to implement an appearance before? Either one of the GXT ones or someone else's appearance? Who's actually tried to implement it and make their own one? What do we think? Pretty straightforward? Pretty easy? No, okay, all right, you're being very gracious there when we're saying so. The basic reason why we do this, why do we even use this appearance pattern, is that way, if you want to, you can replace every piece of it. You can change every aspect about how it is drawn. Now, not everyone needs to do this. Oftentimes, we need to change one single color. We need to change the width of something ever so slightly. We need to add a new icon here. They're very small changes we need to make. And typically with our JavaScript and HTML libraries we've seen in the past, this is usually done by some form of hackery, just saying, okay, I've just finished drawing something here, now let me go back into that DOM element and make a few more tweaks before it actually gets drawn. Or in CSS saying, all right, I've got all these CSS rules that set things up, now let me override those CSS rules and change to something else. Okay, let me override them again because I've changed my mind and I forgot about those rules I already had. Okay, we deleted this widget, but we still have all these rules here. It's a little harder to maintain these. CSS resource and client bundle let us make sure that the only CSS that makes it into the final compiled output is CSS we actually use. So there's a number of benefits we get at production time. But development time has, we found, increased significantly with using the appearance pattern. And this has been a problem we've been hearing a lot about. We've been working very hard on ways to start automating our theme generation. How do we take a basic set of rules that a team has decided, or a designer or a product manager has decided upon, and do all this work for us all at once? So for people who have dug through the source code of GWT.create, they might have noticed that we've got a couple places where we tried to set up a couple of constants. We tried to define a few constants about how we draw things. What color are borders? How wide are paddings? Things like that. And the hope was we could reference all of these things throughout the entire library and get all these colors set in one place so you, the developer, could change this one file and get everything updated accordingly. And there's two basic problems there. The first problem that I didn't mention on the slide is that even if you define a border color, you probably need more than one border color. The grid, you need one kind of color between each column header, and then you want one kind of border at for the rows, one kind of color for the columns. Maybe you don't actually want one for the columns. The panel might need one color. You actually have got a bunch of different border colors you often need to worry about. So we would end up needing to find many, many properties that would define all of these. And it also works when no images need to be created. So if we're building a panel, anyone taking apart the GXT panel, they probably noticed that there are images used to do all the decoration around the outside. So if you give us a new color and say, I want the new border to be this color, we actually need to rewrite all of those images. And we keep those images around because of the browsers out there that can't handle CSS3. Anyone have to support a browser that can't handle CSS3, like an IE6, 7, 8, 9? A few of us? Anyone ready just to drop all of these yet? Okay, all right, we got a few. Let's get going. All right, so we don't need the rest of the talk then if we can dump these. No, but we do need these, unfortunately. We do have legacy browsers. They keep us from being able to move entirely to the CSS3 world. But I think we've got a pretty good solution here. So what are we creating our appearance based on for the browsers that can support it? How are we initially drawing our appearance? Now we could do everything in Photoshop and say slice it all up, cut up little images and make them work everywhere. But as we start moving to smaller and smaller devices with less and less CPU, it's important to use whatever local facilities they've got for rendering this stuff. So we want to use CSS3 gradients. We want to use CSS3 rounded corners. We'd like to use SVG images for icons, because these are already languages that we know, or at least are vaguely familiar with, and we don't have to invent something entirely new. We can use our existing resources that we have as developers for how to write web applications, and we can get them to work in the browsers that we're used to testing with, that run very quickly and can use all these functions. And it also lets us actually get going right away with CSS3 in browsers that support it. So even if we don't have the images all cut up, we know we can still make sure it works with just the CSS3 piece. So once again, let's look at the info example, and here finally is the slide that shows us how to call it. You call info.display, and first you give a title, and then you give the main body message. And when I call this, okay, so how exactly do we render this in CSS3? How much material do we need to make this all work? And it turns out to be pretty straightforward. We've got one div on the outside that says, okay, let's worry about what border style we're going to have, because maybe someone wants a border and someone doesn't. What's the border radius? How rounded are those corners? What's the background color? Let's make it slightly transparent. And finally, let's put a little margin between each one. That way, as you start adding more and more of these, there's a little bit of space between each one. And then for the inner class, we add a little bit of padding to say, push the text slightly away from the edges. Give them a little bit of padding there. So CSS3, this is all we need. If we wanted a gradient for the background, we could have done that for the background line instead. And then for the legacy browsers that can't handle, first of all, transparency can even be difficult. We need to go through and we need to grab those corners, and we need to grab the edges, and we cut each of those pieces out and treat it as its own individual image. And we'll put them on the file system somewhere and say, okay, let's go ahead and draw them in a little bit more HTML content. This is the basic 9-box idea of saying, let's create one element for every part of the thing you're drawing. And then our actual content ends up there, the style.content, style.info. But each of these other 9 ones contains one image to say, here's where we draw that particular piece. Okay, so that's how the info works. Something a little more complicated, tab panel. In a very simple case, we've just got a tab here in a panel, and we need to say, okay, what do we need to cut out of here? What pieces do we need to take from here to make it work properly in a non-CSS3 browser? Well, to start with, we need the corners, right? And then we also need these stripes. Why do we need these stripes? Anyone think of a reason? Well, maybe we don't want flat colors. Maybe we want a little bit of border. Maybe we want a liner on the outside, and then a color on the inside. Maybe we actually, and I apologize for this in advance, shield your eyes, maybe we actually want gradients. Hopefully no one's application is looking like this, but I'm not much of a guy for figuring out colors. So as I put this together, I put the most garish colors possible so we could see very clearly what we might be up against. We still need the corners, we need the stripe along the side, and then we need the background. Anything I'm missing? Anything that didn't get cut up here? We're about 1/3 of the way there. We have almost 1/3 of the images that we need for a tab panel to correctly work. Because it turns out we've also got to have the tab we haven't selected yet. And we've got to have a disabled tab. Oh, and when you hover over a tab, you've got to change it to a slightly different color. You might have a different gradient there. And then you've got the scrolling things along the side to say, okay, if I've run out of space for all my tabs, I need a scroll button on either side. So there's all these different pieces that have got to get worked out and sliced up. And the automatic image generation starts off with a CSS3 implementation, like what we initially showed. 2 divs, simple little bit of CSS. If you can build that, and then you can specify, you can render it in a browser, of course, that's the easy step. You've got to do that as you make sure it works. Specify which elements need images for the non-CSS3 browsers. Collect from that browser, from the running browser instance, what the position of each of those elements might be, how big its rounded corners are, how wide its borders are. Is there a border radius? Is there a gradient? And if so, what's the direction of the gradient? And it turns out we can automate almost all of this work here. It ends up being, for even the tab panel with its something like 24 images, only about 10-15 lines of code to do all this tracking. Decide which images. We don't actually do that ourselves. This is all automated at this point. It says, well, if you told me that you have a border radius of this, and you have a border thickness of this, then you must need corner images, and a top image, and a left and a right image. And then it will go ahead and cut out all those pieces for us. It'll decide background, corners, sides. And then some pieces need to stretch. If we render a content panel with a header with a particular gradient, and then need to stretch it out a little bit, or we need to add more lines of text in it, we need to stretch that image, stretch that gradient image. Now CSS3 gradients automatically stretch. As something gets taller, the gradient will automatically make larger. So we need this system to keep track of all that for us. So through all of this, we've got the rendered browser, we've got the basic metadata about where each image goes. Now we take a screenshot, and then we run it through a different process to go through and cut up that screenshot, cut out images from each of those different places. And this is what the screenshot ends up looking like with, again, my particularly terrible colors. We've got each of the different tab cases we need to draw here. It's a little bit, okay, I can't actually see my mouse. Never mind, I won't point it out. Each of these different lines of text refers to what exactly is it we're concentrating on in this particular image. What are we after here? What are we trying to find? The bottom 2 are looking for the scroll icons. And the top 2 are looking for tabs that are drawn below, so the rounded corners are at the bottom. and the middle two are drawing above, so the scrollers are at the top. This theming generation, this automatic image generation, right now takes about 5 seconds to get its work done. About 3 to 4 seconds of that is launching the browser and waiting for it to display all the different things. And then it's right about a second, second and a half to go through and take this giant image file that we just looked at, except the real thing is much, much larger, and cut all the pieces out of it. And right now that's something like 80 or 90 images it does in less than a second. Sure.
When does that process happen, at compile time or at runtime?
Turns out to be design time. I'll get to that in just a moment. We do that a little bit earlier. It can be compile time, but this is not part of the standard GWT generator step. So if you can take for granted for the moment that we get this image generation done, and we'll discuss more about exactly how it happens later on, we got to back up now to what do we need to actually generate when we talk about a theme. We got to take these smaller pieces, like the appearances themselves, and build the whole body that is the theme. So we've got a way to turn CSS into images. We know that the images and legacy CSS and HTML are used for one set of browsers, and we've got a completely different set of both HTML and CSS that are used for the modern browsers. Did anyone go to the GSS talk earlier that Julian gave? Great tool if you know you've got CSS3 support, or if you know you can refer to things, you need to refer to mix-ins and call these different things. But in our case, we've got basically two completely different sets of CSS, two completely different sets of HTML, and one set of images and one set of not images. So it doesn't necessarily make sense to put everything in CSS. So where do we keep all these config values? And we ended up deciding to create our own config language. It's namespaced, so that way you can say, okay, what do we put at each depth? We've got first the theme itself that describes what's the name of the theme, and which package do I put it in. So when I construct a jar full of this theme, which subdirectories do I put these pieces in? And then the details themselves for the panels, the tab, the grid, the button, the fields. Each of these then go in separate namespaces, and there's a number of things each one needs. So if we look at info, for example, right now this is what the config file looks like if you just describe the info. We need to figure out what the background color is going to be everywhere. We saw these values in the earlier slide. We've got a border radius, we've got the opacity. This one has a slightly different border. This is a 2-pixel border on the outside with an 8-pixel border radius. So you've got this nice line around the outside. And then the margins, the padding, and exactly which font we use for the header versus the message. So this theme config language is namespaced for easier organization. The values can be strings, ints, or doubles, as well as some kinds of objects. Describing fonts turns out to be several different pieces. Padding, you need to describe each of the 4 different sides where you might want to add padding. Some expressions are supported. You can concatenate together strings like you can in Java. You can say, here's an int and a string, put them together and do something useful with them. Values can be referenced by path. So if I've already declared an opacity value up earlier in the file, I can say theme.opacity, or rather opacity equals theme.opacity to reference existing values. So this lets you define in one part of the file all the basic constants you're using and then reference them throughout. Makes maintenance much easier. Oops. And a basic set of util methods. So we noticed a few util methods there already. Font style, border, padding, things that take several simple values and combine them into one larger object. But we don't want to take 10 lines to do any one of these. We'd rather just do it in one line with a few properties all strung together. So when we run the themer, on the zip all of you have got on the thumb drive, there's 2 different zips. One has documentation, one has GWT.create itself. Inside of there, there's a theme builder jar. There's 2 different folders inside of there. One is bin, which contains the binary, and the other is examples. There's 4 different examples we'll talk about in just a minute. And if you run the themer with no input at all, it'll complain that you haven't given it any input, strangely enough. So the basic way to run this is to say, run the themer with some options and 1 or more config files. And the options let you specify, do you actually want to see that image that shows all the sliced up pieces? Do you want to write out the application somewhere so you can run it yourself? Usually shouldn't be necessary, but can be helpful for debugging, especially since this is effectively an alpha build that I've just given everybody. And then the config files themselves. You can specify multiple config files. It will merge them all into one file. We're not really sure exactly how useful that's going to be yet, but we're still trying to figure this piece out. So if you had a config file, if we're in the root of the zip, you say theme builder bin themer.sh. If you're on Windows, there's a themer.bat file. If you're on Linux, I'm sorry, we don't have one shipped on here. The file was so big already, we didn't add it. There is instructions on how to build it for Linux. All you have to do is download a copy of the browser we're using. It's called Phantom.js. It's a Chromium fork, or not really a fork, but it's wrapped around Chromium, and it runs headless. So if anyone's got a build server they're hoping to run these on, this should all go off without a hitch. We're using this in our build server every day as part of our nightly builds. And if you specify then theme builder examples quick start theme, it should run through all these various logging lines as it gets its various pieces of work done and spits out content on the page. We've got 4 different examples included in here, quick start being the one I just referenced here. Quick start is broken into 3 basic pieces to say, okay, we've got a couple of constants that say what color do we want to use for the most part. Right now it's defaulting to a blue. What font face do we want to use? How big should the fonts be? When we build a panel then, and this is the second section, or when we build any gradient, what gradient should we use? And it takes the color you've already given it for headers, and it makes it a little bit lighter and a little bit darker, and it creates 4 different colors and builds a gradient out of that shifts back and forth between the colors. It's not particularly beautiful. I haven't had Daryl work on it yet to make it actually look good, not anywhere near as good as the Neptune theme looks. But it allows you to change just a handful of settings to get a wildly different theme very quickly. And the basic goal there is you can take it to your team and say, what do I need this to look like? Let's change just a few settings and get it maybe 80% of the way there. And then there's the third section of the file, and this describes each of the individual widgets you need to worry about and how to change each one, how to fine-tune each piece. If it turns out you want this particular heading color for all the panels except for info, for example, or except for windows, except for dialog boxes, you can change just dialog box so it no longer references that gradient you defined earlier. The second one we have is called skeleton config. If you noticed from the command line arguments, I don't know if you can read them, there's a generate config line, and if you specify this with a file name, instead of creating a theme, it will tell you all the different properties the theme needs to do its job correctly. And skeleton config is an already built version of this that lists every single property you need along with a little bit of metadata about exactly what should this be and how will it eventually be used when it's compiled. And then there's 2 other pieces for Maven users among us. Who uses Maven? Who actually likes using Maven? Oh, that's disappointing. I like Maven, I'm sorry. I built these 2 different things. The first one we're using internally to be able to say, when I generate Neptune, I don't want to have different CSS, different HTML, different Java files for each theme. I just want to have a POM and a theme file. Put them both in the same directory, run the build, and the POM we've put together will take that theme file and will build an entire jar around it, as if you'd gone through and built each of those themes yourself based on those properties. The second one is Maven source. So instead of Maven jar, this, when you run Maven p generate, it will take the theme file you've given it and then generate source files in your source main Java to let you go through and edit those files to put exactly what you want in them. This way you can start with generated everything with your own fine-tuned settings, and then you can go and start customizing the HTML, the CSS, and even the Java rules to make it fine-tuned to exactly what you need. So you're not required to take the full finished output of the theme generator, but you can fine-tune it after it's been built. Okay, so that's a lot of information and not a whole lot of time. Any questions? All right, we've got a microphone. We're going to try to run around very quickly to bring them. If you can make your way to the sides a little more easily so we can give the microphone to you, that would be helpful.
So the question goes, what about the resolution? I mean, you have Retina Max and you might want to zoom in and so forth.
Resolution is a tough problem. The main issue of resolution we're seeing right now is the double density images you get on these wonderful Retina displays. It turns out that in a lot of cases, making the images twice the size doesn't actually cost much in terms of space. So by default, I think we're going to be shipping double density images. And that will just make it look better on, at least for the tool icons in a number of cases. That being said, how many of us are running browsers that can't support CSS3 on a Retina device? Who's running IE9 on a MacBook Pro with a Retina display? Other than for testing, that doesn't count. So not a lot of people. If it ends up becoming an issue, we will probably also add support for that, either a flag you can turn on and off. Zoom is a totally another problem to worry about. So in mobile devices, we do need to worry about zoom a lot, but once again, who runs IE8 on a mobile device? I9? Please say no. Okay, good. So yes, it's a problem. We can only do so much with images though. We're generally accustomed to using images for these older browsers anyway. We may provide a factor to allow you to make the images larger, but if we do, it's going to be a configurable one. We're not going to, by default, make it possible to zoom in all the way. That's just going to do too much damage to too many other applications. For the most part, if you need to be able to zoom, if you need deeper density, you'll want to use CSS3 anyway. Next question. Someone else has the mic.
Please return to your demo. Turn on developers console and switch to the other theme. I want to see, is it dynamic switching or static? And explain please, no. Please open now developer console and networking tab.
Yes, it will refresh the page when you switch between themes. And the main reason is that that's the way CSS resource works. You actually, once you've created a CSS resource, you can't uncreate it. So you can't go through and get rid of all the CSS that's been created on the page. Okay, so that's not so bad. We could instead completely reinstantiate every single widget on the page. But for doing that, we have to keep track of every state change you've made anywhere on the page. And that's extremely costly in terms of memory. So instead we're doing this from a permutation-based approach, or a property-based approach more precisely. In order to change locale, for example, you have to refresh the browser. You have to load the module again with a different selection property given to the selection script, given to the nocache.js. In the same way, the themes currently require that. Now that being said, I do have a local demo out there I can show which can change some of these things at runtime without refreshing. But it does come at the cost of trying to scrub all the existing CSS. Usually it's just cheaper to refresh the page.
All themes, all CSS resources located in the WAR file on the server side. And when you switch in the theme, new resources downloaded to the browser and page is refreshed.
Right.
Correct?
For CSS resource, there's actually no CSS files at all. It implies that there is, but that's actually not the case. CSS resource includes the entire contents of the CSS selectors and expressions as strings inside the compiled JS file. So in order to get the other CSS, we have to actually go to the server and get other, an entirely other cached.html page.
Understood, thank you. Second question is about custom configuration language. We see that you define your themes config with something new that never seen before.
Right.
So it has many beautiful languages like JSON, XML, for example.
XML is one thing we did consider because at least there's a lot of tools already out there for building with it. And JSON actually doesn't work as well because JSON really is all about literals. There's no concept of invocation, or if there was, we'd have to be writing JavaScript in order to emit our themes. That seemed like trouble. Also, there's no concept of references. YAML is another option where we at least get references but no functions. This was initially for the implementation based off of Groovy, which is an existing language. You'll find that any existing config file, any theme file, is a valid Groovy file. But it's not going to remain true that a valid Groovy file is a valid theme config file. That greatly limits what kind of compilation we can do to it and how we can run it on the client. So we've picked an existing object syntax and are using that here. It turns out to be very easy to parse. I have a compiler, Java CC file that actually describes the language. Yes, we could have picked another language, but the problem is finding another language that happens to have the various features and properties we require. XML came the closest, and I'm a little predisposed against using XML for something quite this massive. Now, if we had completely built a UI to be able to modify all these things so that the XML was entirely generated, I'd be taking a very different approach. But for the time being, we're expecting people are going to be manually editing these files, at least for the 3.1 release.
Thank you.
Other questions? We've got at least a little bit of time, not a lot.
So, from what I apprehend from your initial explanation, there's no way we can create a new appearance for a widget without recreating the widget.
This is true. The appearance requires the widget to give up control of the HTML and the CSS. Without the widget being changed to no longer have that capability internally, there's no way to modify that appearance. That's true.
Okay, thank you.
Other questions? So we can pass the mic along. All right. Well, we're at the Sencha booth out here. If you've got any questions or would like to see it running in person, the build you've all got now takes about 20 to 40 seconds to do an entire theme generation. I've got one locally that runs in about 10 seconds that we're actually going to be shipping as part of 3.1. And I've got another one running locally to be able to test a theme very quickly that runs in less than half a second. One more question?
So I have another question. Or maybe it's possible to show. Can I create my own widgets with Sencha? And isn't it hard to...
It's definitely our intention to allow you to create your own appearances and have this tool be theming them. At this point, with this pre-release, it isn't possible to do this, or there's preview release rather. It isn't possible to do this. The main issue, there's one interface we need to put under your control to allow you to define which properties you need access to inside your appearances. And with that done, you can build your own widgets with your own appearance interfaces, create your own CSS3 and legacy appearance implementations that use the properties from here, and the themer will run and generate the images you need.
Okay.
Other questions? All right. Well, thank you very much. We'll be at our booth outside.